In this chapter, we're going to look at how to test and debug JavaScript applications. We're very fortunate coming in JavaScript right now that there's been a lot of tools developed in the last decade or so to really assist us in this process. Most of the troubleshooting tools that you find in fully functional integrated development environments that you may have used in other languages are available to us through Chrome, so we can run JavaScript inside a web browser and use some of those same tools that we might be used to from other languages. And we're going to take a look at how to do some of that as we go. But let's talk about testing and debugging. What's the goal of testing? So our goal in testing is to find all of our application errors before we put the application into production. You don't want to find them after users are already using it. So we need a good plan to test whatever applications we're writing. The goal of debugging is to fix those errors once we find them before the application gets put into production. Notice both of those. Before the application gets put into production. Before the application gets put into production. We want to solve our errors then. So what are the three types of errors that we can get? As in any language, we can have syntax errors. Those are the errors that violate the coding rules for the language we're in JavaScript in this case. Mostly they're detected by the JavaScript engine when the page is loaded in the web browser, but the IDEs have come a long way. And you know that most syntax errors will probably be caught by your editor. If you're using a good JavaScript editor, they'll probably get caught before you ever get that far, or at least you hope they will. Then we have runtime errors. Runtime errors occur after a page has been loaded in the browser and the application actually starts running. That's when something unexpected happens. It's not necessarily in how we typed a certain piece of JavaScript. It's not the syntax, but it's something like an exception that makes the execution of the application stop because something that wasn't expected has happened. And the last one is logic errors, and those can sometimes be the hardest ones. They're your problem. They're a problem. Actually, they're all the programmer's problem. But logic errors are usually you typed a formula wrong, or you did something incorrectly that causes something to calculate wrong. It doesn't really throw any kind of error while the program's running, other than your results won't be what you expected them to be. So here's an example. Future value calculator. We've seen this one. Total investment of $10,000. Annual interest rate 3.5%. For the number of years is 10. The future value is, what is that, like 10,239,000? I want to go to that bank. I'll stick $10,000 in there for 10 years if they'll give me 10 million back. Obviously, there's a logic error in there. It's nothing that threw an error. Everything ran. It did exactly what it was told to do, except it calculated the value wrong. And that's on the programmer to find that error. So let's look at some common syntax errors. What are the things we need to watch out for? You've probably ran into a lot of these already. So misspelling keywords, like if we write query selector, ER instead of query selector OR, most of the time your editor is going to catch that for you. But be careful. Don't misspell your keywords. Omitting required parentheses, quotation marks, braces, or other punctuation. Not using the same opening and closing quotation mark. JavaScript lets you use single quotes or double quotes for strings. If you open it with a double quote and try and close it with a single quote, you're going to have problems. Forgetting your semicolons at the end of your statements, make sure you put them there. Misspelling or incorrectly capitalizing an identifier, like making a variable named sales tax, that's camel case, it's got the capital T on the second word, and referring it to later as sales tax. And that's all one word, all lowercase, or maybe even sales underscore tax. That can cause big problems in JavaScript, and we'll talk about why coming up shortly. Other times it's problems with HTML references referring to an attribute. So we're looking for a div with an ID of sales tax on it, and we type sales tax with camel case instead of snake case, sales underscore tax. When we're looking for that ID, that's a big error. We want to be careful with those HTML references. Some of those don't get caught quite as easily as other things do. Problems with data and comparisons. Not making sure user entry is the right data type before processing it. Don't process something as a double when it's an int, or an int when you think it's a double, or processing it as a number when it's a string by doing something like forgetting to use parse int or parse float to convert the user's entry into a numeric value. Make sure you're doing that so that the whatever they typed in those text boxes has been converted to an int or a float. Here's another big one, especially for new programmers. The assignment operator is the equal sign. And you're trying to use it to compare two values. And when we compare two values, we use a double equal sign. Or in JavaScript, even a triple equal sign. Always be careful about that. You don't want to accidentally do an assignment operator when you're trying to test for equality. Floating point arithmetic is something we also need to be careful of. The number data type in JavaScript uses floating point numbers, and we can get rounding errors because of that. So here's an example. They're creating let sales amount equal 74.95. Here we're going to multiply that by 0.1 to find the sales tax, 10% sales tax. That's pretty extreme. And then the result, instead of being for $7.50, ends up being 7.49500000001. And one way to fix that is to make sure when we're doing calculations, round. In this case, they're rounding to 2 decimal places, which rounds it to 750, which is an accurate amount for that value. Here's the same thing, parsing the sales tax to a fixed point to get 7.5 as the number. So watch out for the rounding errors. Here's a big one. Students come up to me all the time. Hey, this worked, and I was surprised it worked. I made this variable with the wrong name, and it let me. Okay, so we've talked about strict mode a little bit, and now we're going to get serious about it. If you don't use strict mode and you assign a value to a variable that hasn't been declared, the JavaScript engine treats it as a global variable. And we've already talked about the fact that global variables are not great things. We don't want to use globals if we can help it. It's better to do locals and pass things to and from functions. So here's an example. We have this calculate tax constant here. It's a function. Takes the subtotal and tax rate. It takes the tax rate, multiplies the subtotal times the tax rate. This sales tax is local because it's declared inside the function. Down here, we say sales tax equals parse float, and we take the sales tax and assign it to this variable. Okay. Here's the problem. Sales tax here has not been declared. We declared sales tax with a capital T up here. We've never declared a variable called sales tax. JavaScript lets us do it if we're not using strict mode. Strict mode was created to solve these kinds of problems, to make sure that you don't get these kind of errors in your code. So now we have this variable that ends up being a global variable because it was used without declaring at first. And JavaScript, trying to be friendly, when they wrote this program, they thought, well, let's just make it do all these fancy things for people. And it really created more problems than it solved, in my opinion. But now we have this sales tax variable, all lowercase, that is a global variable, and global variables are not good. And then we return that value. Sales tax isn't rounded, but sales tax is. Our original sales tax didn't get rounded. Instead, this other one did, but it also became a global, and it exists forever. Even after this function quits running, that's now a global variable out there. The solution to that problem, to make sure it doesn't happen, is to always use strict mode. It's one of those things that are hard to find and hard to detect because it doesn't throw an error. You might see it if you're watching your variables in the F12 tools, which we'll talk about a little bit later, the developer tools in Chrome. You might be able to see that global variable out there. You might not. It's just a hard one to find. So always use strict mode. We talked about it early on. I said always use it. Not everybody's using it. After this chapter, from this chapter on, if you're not using it, it's going to be an issue. You will lose points. So here's the future value application when it has valid data. We want to test with valid data. So we put in $1,000, 10% interest for a year, we should get $1,100 back. We've plugged in some good data to test this. Unfortunately, sometimes that's where people stop. Hey, it worked. I put in these good numbers. This is the numbers we're going to test it with, and it worked. Okay, what about numbers that shouldn't work? Are you testing it with invalid data? Test it to make sure that your input validation is happening. So here's one. Let's test it without sticking in total investment first. And click the button. Do we get an error message? The amount has to be a number greater than 0. Do we get an error message telling us that our interest rate needs to be positive? We need to test it with good data, and we need to test it with invalid data to make sure our error catching methods are working. So 2 critical test phases. Test it with valid input data, make sure the results are correct, but also test it with invalid data or unexpected user actions. Go type the word dog. That's my famous test that I do on students all the time. I go somewhere where it's expecting a number and I type dog in and hit the button to see if it's catching any input validation. Is it doing input validation to make sure, and does it tell me that I should have typed a number in that box? Try to make the application fail. Try everything you can think of to make the application fail. Because I guarantee you, when I'm testing your application, I'm going to try and make it fail. And your job is to try and keep it from failing. Sometimes I say that's 90% of programming. That's not quite true. It's maybe an exaggeration, but 90% of programming is input validation. It's not 90%, but it feels like it is. One other thing about that, boundary tests. So if I have a number that's supposed to be between some user input that's supposed to be a number between 1 and 50, what should you test it with? Should you test it with 25? Yeah, maybe. But I would test it, if it's supposed to be between 1 and 50, I'm going to test it with 0. I'm going to test it with 1, and I'm going to test it with 2. I'm probably going to test it with 49, 50, and 51. Right at the boundary, right at the edge. I may even say 50.1. If it's only supposed to go to 50, I'm going to try it with 50.1 and 49.5. Be careful of those boundary conditions. Those are always great places to test your application. So make a test plan. There's people that sit around and write code to test applications. That's their whole job, is write the code that tests other people's applications or test your company's applications. And then every time somebody makes a change in the code, we rerun those tests. And to do that, you have to have a good test plan. Here's the valid entries we're going to test it with. We're going to test it with all these and make sure it comes out with the right results. Then here's all the invalid entries we're going to test it with. And here's what happens or should happen when those invalid entries are made. Make sure you test both. 2 of the biggest problems with testing is not testing with a wide enough range of entries. Try to break your application. The second part that I see a lot of people having a problem with is not knowing what the results should be. Okay? If I stick in this invalid number, what should happen? And does it happen when that invalid number goes in there? You always need to be anticipating and trying to understand what should be happening in your code. That's part of the troubleshooting, is knowing what you're expecting and did you get what you expected. All right, so we talked about testing, debugging. We know what a bug is. Specific kinds of errors, we kind of classify them all as bugs, but syntax errors, runtime errors, we talked about those. Logic errors, we've talked about exceptions and throwing errors. In the next video, we're going to get out some of the tools that are built into the Chrome developer tools, and we're going to take a look at some ways to use those to test and debug our applications.